Everybody, and this is a continuation to my last video in which we kind of exhibited or derived the distance formula and spoke a little bit about the basics of the rectangular coordinate system, but again about the distance formula specifically. And in this one we're going to show a specific example of the distance formula. We're also going to talk about the midpoint formula, keeping in mind that the whole intent of looking at these two formulas and the rectangular coordinate plane is this idea that throughout our class here, we're going to be exploring a lot of graphs. And while doing so, what we really essentially want to do is be able to take a few metrics and measure things like the distance between the two given points or values, or the the midpoint of those things if we're measuring, say, something geometrically. Okay. So let's go ahead and start with this distance formula example. Okay. And what I've done here, if you've been looking over here, I put a couple of points down, but you'll notice instantly what I've done is I've chosen a couple of points that were really convenient here, starting with this one. We say -3 in quadrant 3, and -3, 1. And I chose these 2 points because when finding the distance between 2 points that are stacked vertically or across from each other horizontally, it's not really a shocker. I mean, this is a fingers and toes thing. But again, this was the intent is to show the distance formula in action. So we say, okay, so the distance d between 2 points, given by the square root of, we say, okay, I'm kind of a fill-in-the-blanks kind of guy. It helps me out here, organize my thoughts. But we say that the difference between the two x values, let's go back and erase that. The difference between the two x values and the difference between the two y values, square those and take, sum them, take the radical of that. But let's start with this. The difference between the two y values, y2 minus y1 would be 1. And this is important, 1 minus a -3, which is basically going to flip that back to a +3. Which yields already, we want to say it's 4 squared. Now plus, now let's put in the x values. -3 minus a -3. Okay, so anything minus itself, and in general, but -3 minus -3 is 0 squared. So what we end up with here is the distance between these 2 points is the square root of 4 squared plus 0 squared, which is 16, which essentially comes out to be 4. Or if you want to be, kind of a turd about it, it's plus or minus 4. But in a geometric sense, we kind of, we refer to this as a positive magnitude. So +4. But you know what? This distance formula is going to come into play in many general senses. That is, when we look at things not with specific numerical values, but more with, algebraic variable values. And also, just to figure out distances. So let's go over here and take a look at this idea of a midpoint. In order to do so, how about we go ahead and start by outlining this in the same context we did the last one. And the way we did that was we said, let's say we had 2 points. Again, x1, y1. We say this is general sense again. And x2, y2, we want to find the midpoint between these 2 points. So how about we switch colors again here. But we say, okay, so the midpoint between these 2 points here would be this third point. We can even call this, x sub m, y sub m, to kind of classify it, but not classify, but illustrate it. But we want this midpoint, and so keep in mind we know from the rectangular coordinate plane these directed distances in terms of x and y from the 2 points back to the x-axis and the y-axis. But the reason why this is so helpful is because imagine you had let's say a rope of length 2. Okay, we'll call this 2 units long. We'll call this one 4 units long. And I said, hey, you know what? You want the midpoint of these 2 rope lengths, or give me a rope that's exactly the same distance in length from each of these 2 ropes. So simply put, it's 3. Okay, we got 3. But what I need to illustrate here is this. What if we imagine this distance 2 here? We go ahead and tack it on to the end of this. Of course, we say 2. We're going to find the midpoint. The midpoint, we said, would be 3 right here. Well, you could essentially think of this as is kind of the average. This distance 3 here is the average between the 2 lengths that we've already been given. So if I wanted to say find the midpoint of this little line here, if you could imagine there was a rectangle around this, and maybe we need to switch colors again here. We'll go to like a yellow. Oh, there we go. Imagine this rectangle here. Okay, we want to find this midpoint right there. It would be the average of this length here and the average of this length here. And of course, to find the average between these two, what we'll do is go ahead and sum these two y values. We say y2 plus y1, or y1 plus y2. We'll split that in half. We'll call this distance here, we'll call this y sub m, or this value that we're looking for right there. We say, okay, so the x, we went with the average of these 2 x values, this x value here and this x value up top. So we say, let's add those. We say, okay, so x2 plus x1. we'll split that. We'll call that x sub m. So I'm getting a little sloppy here in my notation, but what I want you to realize is this. We say the new x value, this x sub m, would be given by that right there. So we'll call this the midpoint formula. We say m, the midpoint, or x sub m, y sub m is given by this formula here. We say, okay, so the sum of the two x values, halved in the sum of the two y values halved. And you know, this is a beautiful kind of elegant formula, and we use it all the time. So let's go ahead and give this a shot here. Actually, what I'm going to do is I'll flip over to a new window. We'll do a quick example of what it is that we're kind of illustrating here. Pull this window out here and zoom in, do all that stuff. So bear with me here. But how about we'll go ahead and fill this in with a black color. That's easy to select. And fill, and okay, so here we go. We got our midpoint formula. We're going to go ahead and use that. We say, okay, so m was equal to sum of these two halved. Handwriting's getting sloppy. I'm trying to write fast here. y2 plus y1 halved. And how about we take a look at a couple of points here? How about we'll spread them out. -5, 3, and how about 9? Why not 3? 3 is a good number. So here's our xy coordinate plane that we're talking so much about today. We'll take a look at this. We said, okay, so -5, -3 will hang out down here in the third quadrant. -5, -3. The midpoint of this and 5, 1, 2, 3, 4, 10. How about we go 9, 3, like we got over there. Okay, so these 2 points, we have the midpoint of these 2 points. You know what? The nice thing about sketching it, and I can't implore this enough, always sketch a picture if you can. But is the fact that you can kind of imply as to what the midpoint would be. And you know, on a standardized test, that can be really valuable because you can eliminate answers if at all possible. But we say, okay, the midpoint seems to be in this area somewhere. And I'll draw it really dark here. But we say, okay, our formula stated that m was equal to, I'm going to go ahead and sum the two x values and have those. So the average of the two x values and the average of the two y values, essentially. We say the x values were 9 and -5. So we say 9, -5. And the y values were 3 and -3. So what this essentially yields is, you know, 9 plus -5. We got 4 halves. And over here we got 3 plus -3. Anything plus its opposite is 0. So 0 halves. And, you know, essentially translates to midpoint is 2, 0, which, you know, totally makes sense here if you're kind of thinking about it. So that's a good illustration of the midpoint formula. And hopefully it comes in handy.